Good morning, I am Aher from RBNB College, Rampur. I am from Physics Department. We finished the chapter Gravitation. Now we see some examples and MCQ. Now see the value of acceleration due to gravity. Acceleration due to gravity is maximum first MCQ. The equator of the earth, on the equator of the earth, the center of the earth, the pole of the earth, and slightly above the surface of earth. See, the value of acceleration due to gravity is maximum. The correct answer is the pole of the earth. That is, this is the correct answer. The value of acceleration due to gravity, it is maximum on the pole of the earth. Now second, the weight of the particle. The weight of the particle at the center of earth, is infinite, B 0, C same that of other places, and the last, greater than the pole. The correct answer, it is 0 at the center of earth. The weight of the particle at the center of earth is 0. That is, gravitational acceleration is 0 at the center, and we know weight of the particle, it is equal to mg, and weight is 0 at the center of earth. The gravitational potential due to the earth is minimum. First option, the center of earth, B option, the surface of earth, a point inside the earth, but not at the center, at the center. And the last option G, infinite distance. The gravitational potential due to Earth, it is minimum at the center of Earth. The correct option, it is the center of Earth. The gravitational potential, it is minimum at the center of Earth. The binding energy, the binding energy of a satellite revolving around the planet in a circular orbit is 3 into 10 raised to 9 joule. Its kinetic energy is, first option, 6 into 10 raised to 3 joule, B option, minus 3 into 10 raised to 9 joule, C option, minus 6 into 10 raised to 9 joule, and last option, D option, 3 into 10 raised to 9 joule. The binding energy of a satellite revolving around the planet in a circular orbit, it is 3 into 10 raised to 9 joule. The correct answer is 3 into 9 joule. Why? The binding energy and kinetic energy is equal. Hence, our correct answer is the binding energy of a satellite revolving around the planet in a circular orbit is 3.9 joule, and its kinetic energy is also same, that is 3 into 10 raised to 9 joule. Now we see some examples. The distance between the sun and Saturn is 1.43 into 10 raised to 12 meter, and that between sun and earth is 1.5 into 10 raised to 11 meter. The period of revolution of the earth around the sun is 1 year. Calculate the period of Saturn around the sun around the sun. See here, radius of Saturn, it is 1.43 into 10 raised to 12 meter. The radius of Earth, it is 1.5 into 10 raised to 11 meter. Now, the period of revolution of Earth, it is 1 year. Now, from Kepler's law, we know the Kepler's law, square of period is directly proportional to cube of radius, therefore r cube. We can write for two cases, that is period Ts square is directly proportional to Rs cube and Te square is directly proportional to Re cube. Now simplify or take the ratio of these, that is Ts by T, Ts square by Te square is equal to, substitute the value, that is Kk here constant and gets cancelled, substitute the value of Rs, that is 1.43 into 10 raised to 12 bracket cube divided by the T, value of Te, that is value of Re, it is 1.5 into 10 raised to 11 bracket cube. Now 1.43 divided by 1.5 into, we can take 11 common and we get here, that is 10 raised to 11 gets cancelled. We simplify this bracket, that is 1.43 divided by 15 bracket cube. If we take the calculation, perform the calculation, the answer is 8.66.3 bracket, or the answer of this is 866.3 Ts square by Te square. Then Ts square is equal to 866.3 into Te square. Then Te square having value 1 year, substitute here, Ts square is equal to 866.3 into 1. Then Ts is equal to under root of 866.3 and which is having the answer 29.43 years. Now we perform the second problem. What should be the duration of the year, duration of the year if the distance between sun and the earth where become double the present distance T1 is equal to 1 year, and which is equal to, in 1 year there are 365 days. and the radius r2 is equal to twice r1, r2 divided by r1 is equal to 2. This is the given. We know Kepler's law. T1 square is directly proportional to R1 cube, T2 square is directly proportional to R2 cube. Then take the ratio T2 divided by T2 square divided by T1 square, which is equal to R3 square divided by R2 square cube divided by R1 cube. Substitute the value R2 divided by R1, it is 2 divided by 1 cube. Then T2 square divided by T1 square is equal to 8, and T2 square is equal to 8 multiplied by then see, it is square root of this T2, T1 multiplied by square root of 8 T1. Then T1 is equal to, T2 is equal to square root of 8 multiplied by 365, and the answer is, correct answer is 1032 days. Then now the next problem, calculate the value of universal gravitational constant from the following data. Mass of Earth, it is 6 into 10 raised to 24 kg. Radius of Earth, it is 6400 kilometer. That is, it is 6400 into 10 raised to 3 meter. That is equal to 6.4 into 10 raised to 6 meter. Then acceleration due to gravity, it is 9.8 meter per second square. Now we know the formula, that is Gm is equal to Gr square. Now we have to find the gravitational constant G, that is G is equal to Gr square divided by m. Substitute the value of G, R square and m, we get, substitute the value of G, it is 9.8, value of G is 9.8, and the value of R, it is 6.4 into 10 raised to 6 bracket square divided by mass of Earth, it is 6 into 10 raised to 24. Then see, 9.8 multiplied by 6.4 into 10 raised to 12 divided by 6 into 10 raised to 24. The answer is it is 6.69 into 10 raised to minus 11 Newton meter square per kg square. Now the next problem, find gravitational force between Sun and Earth, mass of Sun, it is 1.49 into 99 into 10 raised to 30 kg mass of earth it is 5.98 into 10 raised to 24 kg, and the distance, average distance is 1.5 into 10 raised to 11 meter. We know the formula F is equal to G m1 m2 divided by r square. Then substitute the value of G. It is 6.67 into 10 raised to minus 11. Mass of Sun, it is 1.99 into 10 raised to 30. Multiply by mass of Earth, it is 5.98 into 10 raised to minus 24 divided by the distance 1.5 into 10 raised to 11 bracket square. If we simplify this calculation, the answer is 35.28 into 10 raised to 21 Newton. Thank you.